Hi, my name is Sergey. So I will talk about how we attack large portals and state-of-the-art technologies. But first, let me introduce who I am, why I'm here, why I'm talking to you. And I work at digital security, and my task is to break something, yes, and so to find vulnerabilities and to show that what may go wrong, and uh, and so I prepare HackWest, and then there is a security conference that is going to take place shortly in Moscow. I will participate. I like to look for things in Yandex, Google, so I love to look for vulnerabilities, and so this is great fun for me. So I always just find something wrong. If I find something is wrong, just I'm happy. I feel accomplished. So then, Haber, just I wrote a lot about security. Then I contributed to Hacker, and I speak at many conferences. But mostly I participate at hackers conferences, hack days conferences, and so because it's good just to talk to developers and to see to get your intake, to provide my points, and very interesting just to operate and work like that. So this is very enriching on both sides, and I love just to make presentations at such conferences. And then I specialize in web technologies, etc. Because so there's frameworks, SPAs, etc. and such things. And I love it. In my presentation, I will try to give you an idea. So the main takeaway that I would like to give you that the modern technologies develop rapidly. So different security systems appear along those lines and simultaneously. And so there are bypasses. So the modern technologies, better security, but all these security measures can be circumvented as usual. So that is why I'll try to talk about the vulnerabilities and how big portals operate. And for example, in Google, and so back hunters and what they do, where they dig, and what they want to do, how they want to make our lives difficult. Lots of vulnerabilities in binary applications and web, but in web, so the most popular is cross-site scripting. Do you know? Have you heard about that? Oh, good. You know what? It's wonderful. That's a new emerging policy. That's cool. So I'm not going just to go into it, but the main idea that in web, the scripting attacks is that the user so puts in JavaScript code, and then it comes up in the browser of the victim, and JavaScript code, and then it will circumvent the policies, so all these letters, for example, so under the name of the user, and the idea is that so you send the script is sent, then you need just to turn it into a safe script, and so then sometimes it's given as it is. So then if you can do that, so $5,000, that's at present, that's good. If anyone wants to try how to do it, so you think it's easy, try to do it, you'll get $5,000. Then it looks like that this is the security is intuitive. The user changes HTML substances and does not allow the user to introduce tags. So for the Mail.ru, Yandex, other big companies, can you imagine how many developers, how many products, lots of applications they have, and how to fight those attacks, how to protect yourself from those attacks. So for example, the user can put the link and not HTTP, but JavaScript.alert1, for example. So then it's replaced. So expected this, but they put it replaced with JavaScript alert one, and then so it's several symbols, everything is fine, that it will be executed. Or another example when it goes into the HTML tags, but it gets inside. Not just between the tags, but the tag and script. So then you need to close the variable and put your own JavaScript function get XSS. So then XSS so in the name of the file. So then Mail.ru, you can filter everything. So and then developers don't even look at some so like loading the file and for example then the JavaScript code is introduced and then it's implemented. So it's my idea is that to understand that XSS. So special charge. But there are more XSSs. From the viewpoint of security for large companies, that's a lot. That's a big tall order. So how to protect yourself? So I made a raw example. So we send a file, scripted a script, then access when it's received, and so they're patched now. And then the info. So XSS is automatic context, aware escaping in template systems, and so for the developer we determine where to replace so the user data, and then when we apply the required filter. So there's a new algorithm. So since we cannot, since the developers cannot write secure code, then we need to have a comprehensive solution. So then context aware escaping in template systems. So as I was saying, so that's for the developer, not the so because they have controllers, they have models, and there is a there's template system that generates templates, and I can imagine that your template system automatically determines where the user's data is inserted, and then using the filter, the required filter, and then XSS will be taken care of. So we have so href. So theoretically, so if you say that we replace it after href, so this is unavailable HTTPS, or we have the template system, so with JavaScript, and then we replace it with JavaScript, and so you can see this in green lines how it's done. And so Google thought about it in 2009 and started to develop their own template system. And so it's still there, and so they use it in their systems. And in 2011, so Berkeley was good paper. And so the essence is quite logical. So when you select a developer, and you cannot guarantee good security of your system, so you need just to be ready to use this system to fend off the attack. It looks cool. So you patch all the holes, but you cannot possibly make it absolutely secure. And so, for example, the task is you're a web developer, and you need just so the task is to trend the system without the template writer on the server, right? So then you have the user input, for example, and so then you put it in the tree to filter, and so without the site, and then so there's a template system kicks in what needs to be done, and there was no solution. But if you one day come across this task, and so then DOM profile solution, so that takes care of the vulnerability, DOM purify, and it can be properly organized. So there are another very vulnerabilities on Google, XSS without template organizer, and so we do the queries on basis of queries, SKU, so from different arrays. And what about the headings? And there was this then heading that in host query, so was put in the body of the response of the answer. So then the template system didn't see it, and so then we can read. So then you follow the link, and so you take it from the head host, from the heading host, and you trigger, and then you trigger the user. So you could do the access attack. So there are these technologies, so the automatic definition, identification of XSS, and so then how can we attack? Second is content security policy technology. Have you heard about this technology, content security? So the whole web is kind of roughly made. So HTTP, so query, so the whole web is a roughly and not strictly designed system. So the browser page with HTML, so then there's a photo, and so then the snapshot, the browser takes everything and just uploads everything. And so it's kind of very mild system and not strict. And they started to realize it quite recently. And so they to think what to do with it. One this content security policy was one of the technologies that tries to streamline it. So that controls all these uploads. And so then the server says so browser so refuse to load the script because it violates the following content security policy directive. Script arg self. That's it. And so this is the whole point. So if a bad guy, so then JavaScript it cannot execute it because it's not allowed. So you can just inline GeoJS. So you can just ban other uploads, other loadings, and because it violates the following content security policy directive, and then you say which one, and so that's how it can be. So for the attacker, it's a very unpleasant situation. So they have an access, but I can't do anything with it. So and the threat is zero. But when you develop, so Russian companies, Yandex was the first. They moved their resource to content security policy. They have special mail, so where it's fully implemented. It's all processed. But when we work with inline JS as on load, not inline but on load, and so they should be banned. And whitelisting of domains. It's a challenging task, so because someone may so upload the scripts and the problems arise. So modern technologies and how these modern technologies can be attacked. One of the problems, Facebook, for example. So there was a very powerful XSS, and the content security policy was implemented there. And actually, you could load the files on domains from whitelist. And so it was possible to do that. So in the messaging and the mail, etc. And so one of the challenges of X. So then it's all strictly forbidden now. So these realizations, and certainly the bad guy cannot upload anything, and whatever. So there's nothing to be afraid of. But so they're trying just to circumvent that, to go around this. So one competition was recently. So then there is this page for JS. So only Ajax goodlipis.com is allowed, and there is an inline introduction. And that's how the JavaScript should be implemented. From this CDN, you connect to the old JS, and the old JS so to implement JavaScript. So that's a good example that shows the code of the sandbox, Word.js, JavaScript between GM blocks. This is not allowed, and so the window object. So how could be done? How it could be done? So the next methodology, OAuth. So about security, they speak a lot about security, and so we have site, and would like your users to be able to safely get an access to the data, and through other users as well, and the third parties could get an access. That's a cool thing. There's some special tokens there, and manage your account like that. So then DigitalOcean attack. I decided to try to break it, and what is safe, what is not safe. And so the bad guy looks at things that are most critically important. For example, OAuth. So if we successfully attack OAuth, so we can get control over the user's account, the user account. So all of them built on Ruby on Rails, the doorkeeper. Make an application, interacts with IP, and when the user comes, so you add this application or not, don't add, deny or not. So that's simple, and that's so the vulnerability in the doorkeeper in the gem that is used not only in the Oceans, Rails, etc. and gem auth very popular. So we take this application and install it, CRF attack. So the user is not aware, so we give him the frame that so secretly so puts this application and installs this application without the knowledge of the user. And then we steal token for the full access to the account. And so what happened recently? So there was a researcher who started to look for Microsoft vulnerabilities and found exactly the same vulnerabilities, and he got $24,000 for taking care of this. $24,000. That's good money. And so through CSRF, so they put the OAuth application in Hotmail and without the knowledge of the user. So these are there's modern technologies, GMA, open source, so they don't guarantee security. On the face of it, it should be secure, but it doesn't guarantee any security anyway. So that's why we need to be more precise about that. Obfuscation is another approach. It's an action when you have a code. And imagine that, so this is a mobile application, for example, so Android application. So it's just given away so to anyone just, and so any bad guy can just download it and then use it against you. So then the logarithm of obfuscation, when the code is given to the user and it changes, and so variables change, methods change, and the application becomes functioning like it was in the original. And so the most recent sub-affair as an example of obfuscation. So mobile cell phones installation, big companies. So when they give out the phones, so company phones, and they have to sign up for them. So they want corporate secrets not to be divulged. So they install such solutions on corporate cell phones. And then when we started to analyze and we downloaded this application from the market, they realized that this application is a zip archive that can be easily unpacked and then put in Java, and and it will not be secure anymore. We opened it up immediately, renamed it, but the methods were quite easy to break this code. Then so when you get an SMS message, this is how they intercept it. So special SMS message to the user. So if Safari begins, so they give an order so to wipe the entire cell phone. So this systemic part, Safari application is used, and there are signatures and an instruction. And so first it should look as yeah, so it looks like an instruction. Wipe the phone, for example. So and the instruction is acted upon, and then so the signature goes back, and then the code is broken in, and that's how it's done. And the rules was that it's transmitter that you can easily find it anonymously. So once you learn the transmitter, you can follow on. And there were two conditions. And so then the signature should be used with the key for the current situation with the installation. But if it never was connected to the installation, it was already installed. And so there was a mistake that this is a secret key dependent on the name of the cell phone that could be easily found out. A certain application is transmitted, and then you can upload it and then and fish out the name of the cell phone. So you can the name was easily ascertained. So the main idea that obfuscation does not mean that you can do whatever you want in your code. Obfuscation is a measure of security at a certain level. But at the same time, it does not guarantee security 100%. So the algorithms that were used were no secret anymore, and so there is technology, and people know about this. And the final thoughts that modern technologies, security technologies, and so they can decrease the number of vulnerabilities, so then and we need just to apply them properly, so but always there are spaces, there are places when no one about which no one thought about, and this is why there will be always new vulnerabilities, new niches, new white spots, and you can always take care because the level of the attacker sometimes. Yeah, it's on the rise, and also files and others. So always check for your status in security. Thank you. Interesting. About the mobile applications. Is there any a size that fits all, where to go interaction and application between the Android applications. We know that, so we know what happens to them, but so no algorithms scripted and work there, but where to store the keys in Android OS. So then there's secure storage system. Yes, there is this so an Android application. So then the interaction between the server and in you. So we need just to keep safely somewhere to store the token of interaction. It's very important. So Android and iOS and all modern platforms, they have a special crypts for storage, which is not accessible to any other applications. So then. And so any application, so you just use it in some special secure space. So if it's stored there, so the keys and then they can be kept safe. Okay, security is very important. Thank you. Question. Framework advises of any framework for testing security. I know only of one framework, which is WASP, so cool. And are there any other frameworks to test? WASP is not a framework. WASP for mini tests to test security because it describes methods and processes as a resource. Yeah, what would you suggest? WASP is not bad. What else? So there are several PDFs that can be read and to take something useful from them. But more centralized than a WASP, you can't find anything else. A WASP is web technologies-wise, and that's the best. So then cell phones, mobile, Internet of Things, then they have chapters, as access protection. Any more questions related to any components of security, digital security? Email attacks. What can you say? Email attacks today. So, on what condition they are? What is the status? Are they more safer or not safer? More vulnerable, less vulnerable through emails? Yeah, safer. Safer if you take the top protection system, top security system. So they are certainly more secure now. More vulnerable. But they're paying more attention now, the biggest companies, so watching the conditions, so the signature analysis, trying to unpack the archives. So sometimes they cannot do that, but basically they are making good progress. And so I can, for example, I cannot Jeff valid Jeff, I cannot send it, for example, because the mail didn't pass it through. And so because of the security system, so so it's much safer now. But phishing is still there, so we need to be aware of that. What is S3? So they are saying like new something appeared through letters that can get to your computer. Yeah. So then 5TSS. So there are some attacks that yes, they exist using this technology. But this client attacks. So it's true that some post message so improperly implemented. The CSS attacks. So the timing and so then in real life it's kind of an experiment. Yes, it works, and in lab conditions it works, but most probably it won't work in the wild. And so let's so then send exploit to everyone, transmit it, and together with the timing, scrapes, changes, and so there are some things, but they don't work well in real life. What about the backgrounds? Yeah, it's true. Then so there are some as a toll browser, and so it should be anonymous, and so cuts away certain things. So for example, so the digital print of the user, etc. But there are vulnerabilities, and some of them are not implementable, and so by everyone. So some can do that because I'm watching it all very closely because so they're trying to design this, but they're not stable. So some of them do work, and so but if there are not many, there are not many. And, so then there's an article dedicated to what you were asking. So then how these modern things, how to open this of content, modern APIs, how they can be unpacked, opened up. Okay, one more question.
We have one more question right there. Please use the microphone. Can you go into detail about key security in mobile devices, everything that is in random access memory? can be detected, and how long does it cost to break through into, or how much is it in terms of money and time to steal a key on a mobile phone? The memory can be read up to an atom. By default, at the level of operating system, everything is secured. In Android, each installation is properly protected. So the operating system tries to, well, in iOS, everything is, well, it's very difficult to attack iOS without a jailbreak. Well, and the shared storage that where we can take the keys to, there are quite few of them. And as far as keys are concerned, well, can you specify? We store keys in a secure storage place of the operating system, and what else can we do? How can we protect it better? We can use the tools of the operating system or use custom solutions to store them on an SD card. There are several options. From the classical point of view, the key can be stored only in tamper-resistant memory. There are some key storage areas in Windows, in mobile devices, yes, and everything must be stored there. This is not an operating system. Yeah, no, this is not an operating system. Okay. Other questions, if any? The question is like this. You regarded Russian and foreign sites. What about the Russian experience in general? What can you say about how well they are protected? Can you compare Russia with other countries? Whether Russian sites are better protected than foreign ones? Is there any other country where sites are better protected or less protected? Well, it depends on how often, how popular is a site. If you are Google, so all the world goes there. If you have a Russian site, only local access is predominant. It's very difficult to use statistics because it's uncomparable. At hackers' conferences, people come from different countries to those conferences. For example, Chinese community is isolated, and we often find a vulnerability which they found years ago. At our forums, we have some solutions which they are still looking for. So there is a problem of interaction and collaboration between national communities. I think that's all. If you have any questions, come to me during the break. Sergey will stay until the end of the day. Let's thank Sergey. And